Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and AWS. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead of us, but first I have a couple of housekeeping notes. First off, today's session is being recorded, so if you miss any of our discussion, you can rewatch this on demand shortly after we conclude. You should receive an email with a link to watch that. If you have any questions, we want you to direct those to the Q&A tab on the right side of the screen. And for any other comments, we want you to use the chat tab. Maybe just let us know where you're tuning in. And finally, at the conclusion of our webinar, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is transform your IT operations with AIOps on AWS. And I'm joined today by Adnan Bilwani, Senior Specialist Builder Experience at AWS, and Bobby Hallahan, Senior Specialist Solutions Architect Observability at AWS. And it is my pleasure at this point to turn the floor over to Adnan to kick us off. But thank you both so much for being with me today.
Hey, thanks for the introductions, Cody. And hey, everyone, good morning, good evening, good afternoon, wherever you're sort of located. Hey, we're really excited to connect with you all here on this webinar. My name is Adnan Bilwani. I'm a senior specialist for the AWS Builder Experience team here at AWS. And just quick introductions to Bobby Hallahan as well, my partner in crime, who's a senior solutions architect at our AWS Observability team. And we're both really excited to be here today to chat about AIOps and how to start looking at modernizing your IT operations with AWS. Now, a quick look at the agenda today. We want to start by discussing some of the what and why on trends we see around modernization of IT operations. We'll take the discussion forward by introducing AI and AIOps. I'm sure most of you know, but just to help set some context, we'll speak about specific AIOps use cases and how to implement them. We'll do a deeper dive with Bobby. We'll walk through a demo, talk about some live examples, and really deep dive into what you can do with this. And then we'll come back and talk about next steps as well. So let's get started. Now, before we start our discussion and really kind of dive deep into AIOps with AWS, I'd love to set up some expectations on where within IT operations we want to focus our particular discussion today. When we speak about IT operations, I've kind of pictured it very broadly into 3 categories. There's release management, which involves deployment of infrastructure and applications, making sure policies and procedures are being followed and enforced. There's also disaster recovery, disaster mitigation, and in some cases there's some overlaps with SRE roles and functions as well, right? You have got automation, possibly testing, release mechanisms, and several other categories could probably fit under release management. Once released, there's that traditional monitoring on infrastructure and applications, right? This includes all your applications and resources, the events, traces, metrics, log data, and all this covers both, right? Cloud and on-prem potentially as well. And then last, there's that incident management category as well, right? Ticketing systems, incident workflows, there's talk of uptimes, SLAs, SLOs, COEs or correction of errors, root cause analysis, all can be sort of grouped into that incident management category. For our discussion today, we'll focus on monitoring when it comes to IT operations and speak about solutions that AWS offers to implement AIOps for monitoring your resources and infrastructure in the cloud. So with that in mind, let's start by speaking about some of the growing trends in 2022 we're noticing around modernizing IT operations. First of which is the growing amount of data points operations has to deal with on a day-to-day basis. And why is this data growing? Simply speaking of growth from a customer point of view, right? As your business is expanding, your digital infrastructure is also potentially growing. The number of apps, thus the number of resources, are also growing to just keep up with the growth of the organization and its needs. Combine that with the fact that, as your DevOps culture matures, the pace of releasing new versions or changes, is really accelerating as well. And then let's not forget the microservice architecture conversation, right? It's all about providing patterns of a distributed application, which also leads to more resources and more metrics and logs being generated that need to be ingested as well. Due to this rapid growth, right, monitoring activities are also growing for operations to kind of keep up with that. Add to it, again, the conversation around SLAs, SLO requirements, an operation constantly has to think about how to scale as the volume of data being ingested for monitoring keeps growing. And it's just not about creating and monitoring the alarms, right? It's about proactively looking at thresholds and when those alarms go off, changing those thresholds as app and traffic trend changes, right? So we got to kind of look into all of that as we kind of go forward and expand. Then there's always this talk of, or trend, you may say, for a shift left for IT operations, right? In other words, it's about sort of having developers start thinking about uptime, monitoring, SLOs. So applications are more resilient once deployed to production as well, right? So we want to align developers to operations early in that development pipeline. But the catch here is to provide them tools or resources that give them the insight into their applications, but let's not burden them with the heavy lift of operations, right? How do we kind of introduce that as well? And then last but not least, organizations want to use their operations staff as skillfully as possible, right? Leaders want their IT operations team to have even a more elevated role of analyzing trends, focusing on automation, improving SLAs, instead of just worrying about managing alarms and in that area as well. All of this really creates complexity, which exceeds human scale. And this is where AI comes into place. You've probably heard of AI described in a number of ways. So I'd love to take a step back about, and just talk about what it means before we sort of dive into it. AI, if I were to define it, right, AI is a way to describe any system that can replicate tasks that previously required human intelligence. This is almost always related to some kind of complex decision making where human intelligence is required. Most AI use cases are looking, for a probabilistic outcome, making a prediction or decision with a high degree of certainty, kind of similar to human judgment. Now, we hear the term AI and ML usually a lot together, right? So let's kind of define ML too as we sort of go on. Almost all AI systems today are being created using machine learning. Machine learning uses large amounts of data to create and validate design logic, which is also known as models, right? That's kind of what ML is all about. The AI application then basically feeds the input data into that model, and you actually model, and your models then output basically human-like decisions, right? So machine learning is kind of the underlying technology powering these intelligent systems. Now, let's think about using AI in the context of IT operations as we kind of narrowed and defined it at the start of our discussion, right? Think about the traditional workflow of IT operations today. Applications produce metrics, logs, and traces, requires you to set up alarms and dashboards to then monitor all that data. And then as alarms go off, right, you create some sort of a notification. It could be a ticketing system, chatbot, anything else. Then someone has to sort of determine whether the alarm is really valid, was it a temporary hiccup, or is it just due to a natural increase in traffic in your app, right? What if you could, at that point in time, use AI to add some intelligence to parse through all the noise and surface only the appropriate signals? In other words, use AI to detect behaviors that deviate from the normal operating patterns so you can identify operational issues more intelligently, aka AIOps for monitoring. I mean, in fact, even Gartner predicts, right, that 40% of DevOps teams will augment application and infrastructure monitoring with AI for IT operation capabilities by 2023. So this is sort of where that whole AI ops conversation comes in, right? With AI ops, you could automatically analyze these trends to set up and update those alarm thresholds rather than actually manually trying to work them out or trying to create something to make it happen, or auto detect issues you may not already be looking for. That's all very important, right? And differentiate that signal from noise and even sometimes maybe provide context to your operation teams when they get notified of a potential issue. Now, I'll take a step back and say you could build this AI yourself, right? Even AWS certainly provides you the resources to do so. You've got SageMaker and other services that offer you the flexibility to train and create your own data models. And you could indeed build and deploy your own. But today, what I really would love to focus on is what AWS has to offer that can help you automate without the need of creating and maintaining your own intelligence or models, right? Help you avoid that heavy burden and start thinking about how you can utilize a few services within AWS to easily start your journey using AI for your IT operations. Just a small plug for all the business owners that are listening in, right? From a business perspective, right? This is also about enhancing your customer experiences, right? Enabling your employees and business units to make better and faster decisions. Also improving business operations while reducing cost potentially as well. And at the same time, growing their teams and really helping them take advantage of some of the new technology to elevate their workflows as well. But let's come back to sort of the meat and the nitty gritty, right? How do we do this with AWS? Well, let's start by walking through what you may have today within AWS itself, right? You have your input signals, and those can be system level metrics from, right? You've got your EC2 metrics, you've got your custom metrics, vendor CloudWatch metrics, application logs, and trace details. Where are all these stored as they get produced from all your resources? They're all stored across several different data stores, right? You've got CloudWatch, you've got CloudTrail, X-Ray, Config, Performance Insights. Now, typically, you would take the data from those data stores, and you may have alarms set across these metrics and log data. You may have visualization set up for 24/7 operations. But as you realize, right, scaling this can be a little bit impossible. That's where sort of this whole conversation around AI/ML or that AI/ML layer comes in. And I want to start by narrowing that conversation and simply introducing to you CloudWatch Anomaly Detection and Amazon DevOps Guru to help you sort of augment your ITOps resources and really surface signal from noise. Let's take CloudWatch Anomaly Detection, right? With its root in over 12,000 machine learning models, anomaly detection provides you a very simple way to create smarter alarms, with a threshold that adopts and changes with your application trends to kind of minimize that noise. But let's not stop there, right? Anomaly detection is all about monitoring what you think you know or you know is important. What about everything you did not anticipate, right? That's where you can actually activate a service like DevOps Guru to continuously analyze and consolidate streams of operational data from multiple sources. Again, the CloudWatch metric data, the CloudFormation and X-Ray, and even RDS Performance Insight data to sort of give you a single console dashboard to search for or provide you other basic ideas of automation for your operational data when issues sort of arise. Let's do a little bit deeper dive. We've kind of set up where we're trying to go with this. Let's take a quick look at some specific use cases to see how this benefits your operations, right? So let's start with a typical serverless application. You've got Route 53, you've got your interfacing with your users, behind which you have CloudFront. You've got API gateway to service both static and dynamic content. You have Lambda functions, right? Speaking with other functions or databases such as DynamoDB or RDS. And all this is generating a lot of metrics, logs, and trace data. And it's being sent to your dashboard or monitored via alarms by your ITOps team, right? When you have spikes in workload, fluctuations, how do you sort of manage those things, right? These changing thresholds for alarms, you got to keep a constant eye for what's real and significant versus what's not. This is kind of where adding that layer with CloudWatch Anomaly Detection and DevOps really allows you to be more prescriptive and apply that ML to model all those signals and really automatically surface those significant events, right? Think about it. You could have DevOps Group proactively monitor the metrics. So you've already got CloudWatch Anomaly Detection set up. You've got smarter alarms set up. They're monitoring what you already know. And then on top of it, you've got DevOps Guru, which is monitoring all the metrics and really helping you surface things that you may have not anticipated and really provide you detailed insights. Let's do a little bit of a deeper dive on how it helps in this use case and specifically now talk about both. So here's a normal CloudWatch alarm, right? It's a metric. You're looking at request counts on your API gateway. And as you can see, right, I've set it to about 600, but you do have these fluctuations that, trend higher at times. And if you look at that, you'll see that CloudWatch alarm could generate noise or additional noise, which you may not want, and you would like to just, talk about some of the outliers there rather than the typical trend that is sort of scaling up and down. That's where basically you could actually convert this alarm to a CloudWatch anomaly detection and enable CloudWatch anomaly detection, on this alarm. And you can really identify that range and create a band of top and bottom that you can actually even adjust further and fine tune as you desire. And it helps you really just surface those critical events rather than kind of, provide you noise on all the fluctuations themselves. Let's also take a look at a different scenario, and I know Bobby will go through a lot of details in his demo on this as well. But this is again, let's talk about the serverless web application, right? Let's utilizing API Gateway, Lambda, DynamoDB. Your users are experiencing 5xx errors, right? You have multiple alarms going off across different resources. How do you determine the issue? And did you have those alarms set up to begin with, right? An insight from DevOps Group could really help you provide that single pane of glass to evaluate this for your operations team. It automatically correlates the issues, as you can see, across various services and resources if you look at the timeline, and it really helps you identify that the issue really started from throttling in your DynamoDB resources rather than any other place. If you scroll down at a single screen or a console from DevOps Guru, you also provide you additional context via CloudTrail data that the issue potentially occurred due to a change in the deployment stack. And moving further, the machine learning models even provide you recommendations to your operators to provide you guidance on the issue and provide you possible remediation steps as well. But we talked about serverless, right? That's great. But what about other things? What about EC2 based or lift and shifts, right? Well, you could use Systems Manager to automatically deploy CloudWatch Agent, again, to collect custom metrics that you may have proposed and set up. The metrics can then be reported to CloudWatch, and then you can, again, put the smart alarms, CloudWatch anomaly detection, to kind of fine tune your reporting and alarms, again, to reduce that noise and really surface, the appropriate signals. Container-based applications would be a similar concept, right? Again, using container insights, whether it's EKS via FluentD or ECS via FireLens, you could again transport those metrics and the data up to container insights or up to CloudWatch and basically take those and set smarter alarms and really help you use those machine learning models to really surface what you need to see and help your operations as well with deeper context. All right. I've had enough kind of an introduction, hopefully, to provide you with where we're kind of going with it and how you can start using AI. I'd love to turn this over to Bobby to provide you a more deeper demo and really get your hands dirty on that. Bobby?
Yeah, sure. Thank you. Alrighty. So, welcome to our demo today. In today's demo, we're going to take a look at a sample application we have set up. This application is a pet adoption website. So part of this pet adoption website allows us to search for different types of pets based off of the pet type, pet color. And then, of course, we can adopt pets too. A quick overview of what this looks like is, from an application standpoint, we have an ALB fronted with an EKS cluster serving as our front end. This EKS cluster is running on EC2. From here, we have a couple other ALBs that are supporting a search API, a list adoptions API, as well as a pay for adoptions API. All of these are running on ECS on Fargate. From here, we also have a couple step functions to Lambda, as well as an API gateway, Lambda, and DynamoDB type setup here. Okay, so with that said, let's go ahead and take a look at a dashboard that we put together to help us understand some of the findings we get from DevOps Guru, as well as where we can see with anomaly detection as well. So what we can take a look at here from the dashboard at first is we can see I'm leveraging text widgets to give me some information and context, give me helpful links. I can also include text widgets to give explanation or additional context into the type of panels I'm looking at here. So from here, we can see I have a DevOps Guru widgets giving me a link directly to the console, as well as giving me the count of insights over time. So total number of insights based off of insight type. Today, I have a just reactive insights, but if I had any proactive insights, they would also show up here. We're leveraging a dynamic labeling as part of this dashboard as well. So what we can see is instead of just showing the count of insights, I'm also showing the last time that insight occurred and then the last relative time. So my last insight was 7 hours and 4 minutes ago. From here, I'm also leveraging a custom Lambda function, or a Lambda-backed custom widget, which is a new feature to CloudWatch dashboards, which allows us to create widgets that will invoke a Lambda function. That Lambda function will then, whatever it returns, can be rendered onto our dashboard. So in this case, what I'm doing is I'm calling the describe insights API and then rendering that on a table, showing me the time range of when it started, the severity, and status, as well as constructing a link directly to the issue. Okay, so back to the walkthrough on our dashboard. I've also created a couple different anomaly detection bands here. And what we're taking a look at specifically first is the target response time metric for our pet adoption ALBs. So all of our ALBs have different target groups, and we're looking at the overall response time. So you see I have one for the pet site, which is our front end, the list adoptions API, pay for adoption, search service, and then I also have some traffic generators that are sending requests here. Okay, what we can, oops, sorry about that. I'm using a trackpad today, so if the zooms are a little awkward, please bear with me. Now, what I want to show here is specifically, let's take a look at a 3-hour window. That in this case, like static thresholds may not be the best use case here if I'm looking at target response time. And that's for a few reasons. One is I can't necessarily state a static threshold that would apply to everything, right? So for example, if I were to say, closer to the max here for the pet list, site, it's about 0.33. I believe that's seconds for a target response time. Now, actually, I believe it's in milliseconds. But anywho, if I were to set an alarm threshold, let's say here, what would happen is potentially I would get alarmed when during these peaks, which could be a good thing. However, that static threshold isn't very useful for these other metrics. So what that would cause me to do is then have to set a static threshold for each and every single target response time, and then understand what that average should be over time. Now, that's not completely unrealistic to do. The longer you operate an application, the longer you operate a workload, you're better able to iterate and understand what that average profile would look like. However, let's say we jump in and we don't necessarily know what that average should be or where we should be alarming. And to help with that, we actually created, I didn't create it, but our CloudWatch service team did, is anomaly detection bands. And what we can see here is a target response time. And then to the right hand of that, I also have a target response time just as the metric. And here I have set the alarm threshold. So you can see every time we're crossing this peak or this line, that would actually trigger an alarm state. However, if we take a look at our target response time from the anomaly detection band, we don't necessarily see this falling out of the norm. So this is one of those use cases where we're actually able to eliminate alarm noise. And then on the left-hand tab here, I also have the alarm status. What you'll notice is on this widget where we have this little line indicates that this is an anomaly detection based alarm, where the one that just gives us that check is the static threshold. And of course, where static thresholds can also be valuable, just as anomaly detection, if we have these large spikes for a period, of course, this would trigger the alarm as well as the anomaly detection band. And then, of course, you can see similar to where we're graphing anomalies, we're also graphing our target response time. But what's great about anomaly detection is you're able to set it, and then you have some configuration options available in determining what that detection band would look like. However, you don't have to just guess saying, okay, I'm assuming that this should be my response time, and I'm going to statically set. If it goes any above this number at all, then we're going to alarm. In some cases, with some metrics, specifically things like request count or target response time, anomaly detection does make a lot of sense. Okay, so if we take a look at a 1 hour period, we could get a better view here, or even a 3 hour period. Now, what we'll notice here is once we update our time periods, right, we're looking at a specific window. So if I go from 3 hours to 1 day, we can now see we have additional insights that were raised from DevOps Guru. Or even if I go from 1 day to 3 days, or even let's say 1 week, you'll notice that we get even more insights that are displayed here from anomaly detection. Alrighty, so let's go ahead and take a look a little bit deeper into the dashboard construction here, just to show how we're doing and how we're doing a few of these things. And then from there, we'll jump into one of these insights on DevOps Guru. And then we'll also go about showing some of the insights we can get from X-ray insights. So it works very similar to DevOps Guru, but where DevOps Guru is looking at log and metric data, what we're using with X-ray insights is specifically trace data to help bubble up where those anomalous behavior is, and then identify which specific nodes in your application could be causing that alarm or could be causing that problem. I would say if you are using X-ray today, or you are instrumenting your application, either with OpenTelemetry, or maybe we're using X-ray and we're sending that trace data to X-ray, definitely check out X-ray Insights. It's incredibly valuable. Okay, so if we were to go edit this specific insight, what I'd like to show here is one that we're using a search expression. So I am looking at DevOps Guru, and then the insight, the metric name is Insights. The sum is 60. So the reason for doing this is DevOps Guru actually produces 2 different types of insights, proactive and reactive. It also emits metrics for both of those. Since I don't want to just statically define both of them, or in this case, since I don't have proactive metrics yet, I don't have the option to select it. So what's nice about a search expression is once a new metric with a different dimension is populated here, it will automatically be included in the results of this expression. A couple other things I'm doing here, including the last time. I am using dynamic labeling so I can show the last time as well as last relative time, which is 7 hours and 12 minutes ago. Some other options you have for dynamic labels include different properties. So I can grab the namespace, region, account ID, or I can expose a specific dimension key value from there. I can show elapsed time since, difference in values. I can do any statistical notes that I'd like to show. So the maximum of all data points, data point count, average of the data points, all of these can be expressed here, which can help make these widgets a little much more powerful. And of course, I'm using a number, but then there's a few other options here as well. Similar to the total insights, just like we mentioned, using a search expression. So once proactive insights do appear, we should have those populated below. Now for the fun stuff, let's take a look at our custom Lambda widget. And what we can see here is I can do a get documentation, and this will show us actually invoke this Lambda function and explain what parameters it's expecting. And let's go ahead and take a look at the Lambda function within the Lambda console. All right, so, and I will actually zoom in my screen more here, so it's a little bit more legible. All right. And how I got started with this, I actually used, and you might be able to call this out if you pay attention to where I commented out a few things. I actually used a blueprint for listing and describing EC2 instances in a table. So this is one of the many blueprints we have for our custom Lambda widgets, where when I want to create one, I can hit a drop down, and I'll show that quickly here. Just in case if you wanted to test this out on your own. So I'll select a custom widget. From here, I have things like debuggers, but I can also make an Athena query. So imagine if you have your cost and usage report writing to Athena or any other type of data that's in Athena, you could query that with a custom widget and expose that on a CloudWatch dashboard. I can make any AWS API call. So think of like describe calls where I have an application, but maybe there's other resources that I want to call from AWS, maybe like code pipeline, for example, or maybe I want to list and iterate over S3 buckets or EC2 instances. I could display contents from a specific URL, fetch an S3 object, do simple pie charts, or load up a table showing EC2 data. So really easy to get started. And what I did is I just used the EC2 table Lambda function. And then from there, I made some edits. And the specific edits we made here are, we'll walk through these functions here too. Okay, so here we have our exports handler. So this is where the entry point for our function. We have our widget context. This tells us information about the widget, like the time range, where the widget is positioned, what dashboard it's coming from. And then we're just setting our time range, start time, end time. We're collecting the region. We create a DevOps Guru client, as well as a CloudWatch client. We could ignore the action for reboot because we're not necessarily doing anything. And the next thing we do there is we just call get insights, where we pass our DevOps Guru client, start time, and end time. What get insights does is we create a filter where I'm just looking for the given start and end time. So whatever start and end time I'm displaying on my dashboard, that's what this Lambda function will use. And then I'm filtering just for reactive insights. We go ahead and list those insights, iterate over them, and then we return the insights back. From here, once we have our insights, the next thing we do is just get HTML output, where we pass in our insights, which was returned here, region, context, and event. And then in our get HTML output, as you can see, we form a nice little HTML table. And then I am just mapping in the properties from each of the insights that are returned, and then even constructing the URL here. So relatively straightforward, but I did want to take the time to walk through and make sure everybody knew that you could take an existing, one of these existing blueprints and modify it pretty easily without having to be very experienced in programming. All right. And then just to highlight a couple of the other widgets here. For alarms, it's relatively straightforward. We can just select which widgets we like to use. And then we can display them on this table. Very last thing I'll show is one of the options we have available for a time series data point, which is actually setting horizontal annotations. So I manually added this horizontal annotation. I gave it a label and a value, and I can go ahead and add a fill color to it as well. We also have the option to add vertical annotations if we'd like to. And then last but not least, we also have the option to modify our anomaly detection band. So let's say we have maybe we're saying this band isn't aggressive enough, or it's not catching enough anomalies. We can easily change this from 2, right? We can change this to 1 standard deviation. And we should get a stricter anomaly detection band that will apply upper and lower threshold values appropriately. If you're curious about how anomaly detection works and how we do the alarming, I can actually just remove the specific time series we're evaluating, and you can see you have an upper and lower threshold. So we're actually producing upper and lower expected bands from this anomaly detection math expression. And then when we overlay it with the actual time series point, that's how we're able to determine if it falls above or below a given threshold. Now, anomaly detection can be great where you know what your KPIs are and you know what metrics you should be looking at and you know what you should be alarming on. However, let's take the point where even in this, where are we? Even in this application, there's a lot of different components here. And if I'm just operating this on day 1, I may not know exactly what to look at or what patterns could be indicative of an error or some sort of error state. This is specifically where DevOps Guru can be incredibly valuable, because when we're looking at specifically mean time to detect, this is a metric that gets better over time. The longer you operate an application, the longer you operate and manage a workload, the more effective you are at determining, going back and catching those things that may have caused an application outage or some downtime or some SLA breach before. Go back, do some sort of root cause analysis, and determine, we should have been alarming on this given output signal and we weren't. So let's take a look at a given insight here. I'll pull up 2 for us. So we have application ELB 500s and DynamoDB read throttle events. And here we can see the overview of our insight. We can see which resources it was able to find those on. So we're correlating our metrics here. We have our most recent deployment. So we know it wasn't necessarily related to a deployment. I cheated here because I do know what it's related to. I increased the traffic by about 50 or 100% on this workload. But if we were to take a look at our graphed anomalies, we can see where we're pulling the 5xx errors from. And now we know that this is potentially something we should be alarming on. And in my dashboard, I wasn't beforehand. Another example of this is by looking at DynamoDB read throttle events. So here we can actually see where we're correlating from a few different places. We have the sum of throttled events, our target response time in P99 from our application ALB, and then the read throttle events, so specific to the operation. And what's interesting here is now we're correlating across many different services. Well, in this case, just 2, right? We're looking at our application ALB where we see a high target response time, but then DevOps Guru is smart enough to be able to determine that this is actually coming from DynamoDB, specifically read throttle events. And if we were to take a look at our graphed anomalies, we can show each of the anomalous behavior across these different metrics. And then, of course, we have recommendations on what we would want to do here. So like I said, in this case, even in our dashboard, we weren't necessarily looking at read events, throttled read events, but DevOps Guru was able to highlight that for us and show us that, hey, here's an insight, and here's the related resources, and here's what we think potentially the root cause is. Now, instead of just being able to show that on a dashboard, for example, we could easily say when these insights come in, we can send them to SNS or EventBridge and then take action from there, process them from there. Now, lastly, what I'll like to show us is X-ray insights. So similar to how DevOps Guru works, but like I mentioned, it specifically looks at trace data. So we'll go to our insights and we can see, let's take a look at one where we had overall 1.2% of requests to our adoptions database failed. This lasted for 4 minutes. and we can see the start time here. So we'll open that one up, and we'll also check out a different one here. Let's check out one with our state machine. So here what we're looking at is our X-ray insights for a specific error from our application. So we can see where we're grabbing the anomalous behavior. And then we're also being able to plot out what our root cause is. So if you take a look at the specific nodes, or all the different service nodes in our application here, we're actually able to pick out where the anomaly is. If we were to go further and inspect this, we'll even generate a service map from that given time range, which is nice because sometimes you're just looking at a service map. If I were to go view the service map in real time, it may not highlight this, but what we're doing is preserving the service map during that time of the event. And then here's another example where we're looking at our step function state machines, where we're able to generate a service map for the time of the error. Where we're actually being able to show the root cause as well, or the expected root cause. Okay, so with all this being said, I guess where probably one of the biggest takeaways here is when it comes to understanding the health of your workloads and the health of your applications, in some cases, static thresholds work very well, right? For your SLAs, SLOs, that's great to have a static threshold. If you have your KPIs and you know what those are, it's awesome to have alarms on those. But in some cases, static thresholds may not be applicable, or you may not know exactly what normal looks like. This is specifically where anomaly detection can be valuable for us. And then when we also want to look at is, we have to ask a question like, we don't know what we don't know. We don't know what types of error behaviors there are, what types of patterns produce errors, or what other signals we should be looking at potentially to alarm on. And I feel that this is specifically where something like DevOps Guru, as well as X-ray Insights, is incredibly valuable. But with that, that does conclude the demo that I prepared today. And I'm going to go ahead and pass it back to Adnan. He's going to walk us through a couple of the next steps you want to be thinking about when incorporating AI and machine learning into your monitoring and observability strategy.
Hey, thanks, Bobby. That was awesome. Let me go ahead and just quickly reshare my screen. And while I kind of go through this, I hope the demo was really useful and kind of provided some insights into sort of, when we talk about AIOps and we talk about services, they'll help you automate AIOps, right? And provide you some of those easy and low-hanging fruit to sort of adopt some of those things into your application workflows. You got a good sort of look at what you can kind of quickly get at. And I'm sure, there's a crowd here where, some of it was new. For some, it may have been a little simple. Maybe you need more or want more. But the idea here was to sort of introduce you to the concept that, hey, we don't have to create our own just yet. If you're looking to sort of adopt AI for your operational data, there are easy ways to sort of do that, or at least automated ways of doing it, where you can adopt certain services and go from there. Hey, so how to get started, right? What's next? Let's just talk about that for a minute, right? It's not done in a day, for sure, right? I think you have to identify sort of the low effort, high impact points or applications that you can potentially use, right? Where will it be most valuable to you to sort of test it out? Possibly look at the current metrics, right? You're watching. Are you able to successfully track everything now? Are there any service level objectives or noise that you're getting from a certain application that you'd like to sort of work on? find that low-hanging fruit, right? That you can experiment with and sort of test this out. Possibly, again, if you look at some of these things, they were all sort of observe and report scenarios, so you could easily do this within production application and really implement this and verify results with a few of your applications. Start there, see how that results, what happens, verify the results, and then sort of iterate over time and expand, right? That should be hopefully to gain out of this as well. Hey, if you're looking for more, if you would love to have more details, we'd love to sort of help out as well as we can. So, please connect with us at the email below. We're more than happy to sort of help engage and provide you even more details if we can. But we really appreciate your time today. I see Cody's message, and last call to send any questions you may have for today. Bobby, any last words of wisdom you can add? We sort of.
Not that I can think of. It's still a little early for me. But would you be able to put that email alias in the chat just in case anybody wants to grab it?
Yeah,
or didn't have time to note it down.
Yeah. So, Bobby, you want to answer that question? I just see a little comment there about, does the AI only apply on data on AWS services?
Yeah. So, excellent question. And the answer is it depends, right? So, if we're taking a look at anomaly detection, what we would want to be able to do is essentially anything that exists as a CloudWatch metric is valid for anomaly detection. Meaning that you have AWS service vendor metrics that come from EC2, RDS, VPCs, Lambdas, because VPC doesn't emit metrics, does it? Lambdas, API gateway. However, I can also extract custom metrics either through application logs, or I can have my application emit those metrics directly. Since those exist as CloudWatch metrics at that point, anomaly detection is totally fair game, as well as any other type of math expression I'd like to run. Similar to a point with X-ray insights, where those insights, for the most part, you'll notice that the nodes represent specific AWS services. However, that doesn't mean necessarily that it's only AWS services. So with X-ray, I can instrument any at whatever granularity I'd like to. So I can have specific function calls in my application represent a node or segment, and then from the X-ray insights perspective, it doesn't really care. It's just looking at the service lens and determining where that anomalous behavior is, be it an AWS service or a custom node that you've instrumented. It shouldn't make a difference.
Thanks, Bobby.
Yeah.
Great. Hey, really appreciate the time. We want to be conscious of the time you spent with us, and I hope this was useful. Looking forward to sort of engaging anyone who is interested, and hoping we were able to share some knowledge that will able to help you out and sort of looking and start thinking about artificial intelligence or AI with your operational data. But with that, Cody, over to you.
Thank you, Adnan, and thank you, Bobby, as well. I really appreciate the time that you took to dive into that demo and really show us how everything works. So I really appreciate the time and thought that went into this presentation for the both of you. So I'd like to quickly remind our audience that today's session was recorded. So following this panel, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the DevOps website. Just visit devops.com/webinars and look in the on-demand section. So we do have 4 $25 Amazon gift cards to be giving away. Our first winner is Cal H. Our second winner is Turk S. Our third winner is Elaine Z. And our fourth and final winner is Ellen R. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. I would like to extend our gratitude to AWS for sponsoring today's webinar. And my final thanks, as always, goes to you, our audience. We appreciate the time that you took out of your day to spend with us and for sticking around for the entirety of today's presentation. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future Techstrong Learning webinar. Everyone, have a great rest of your day.
Thanks, everyone. Bye-bye.
Thank you all.